Hello and welcome to our channel. As part of our organic chemistry unit, today I'll be discussing the basic functional groups and how to identify them. To learn how to put this identification to use in nomenclature, check out our organic nomenclature video. This video is primarily about identifying and tips for naming that particular functional group. It does not contain in-depth information further than that or about reactions involved with those functional groups. Alkanes are sort of a functional group. In a literal sense they are, but there isn't really an identifying feature for them. They are identified more from the lack of presence of other functional groups. Alkenes have a double bond between carbons located somewhere on the main chain of the molecule. For smaller chains where the location of the double bond can only be in one location, like propene or butene, you do not need to indicate the location of the double bond. Your numbering of the main chain should reorient itself to make the double bond the lowest number location if possible. Aldehydes have the CHO group on either end of the molecule. This will visually be a double bond O with a lone H attached to the carbon. Aldehyde groups will have to be on the end and will always be the beginning of the chain's numbering. Ketones have a C double bonded to an O and will never be located on the end because that would result in a CHO, which would become an aldehyde. Similar to alkenes, location only needs to be indicated when there are 4 or more carbons on the chain. Carboxylic acids have the COOH grouping, which is the C double bonded to both an O and single bonded to an OH hydroxyl. COOHs will always be on the end and become the first carbon for the sake of numbering. Esters are 2 chains connected by a COO, which is a C double bonded to an O and single bonded to another O. Both parts of the chains are indicated in the nomenclature alphabetically and not by length. Easily confused with esters are ethers. They are 2 chains connected by a sole single bonded O. They are named by length with the shorter listed first. Similar to carboxylic acids, amides have a C double bonded to an O, but instead of a hydroxyl, there's an NH2 group. Amides will always be on the end and are the first carbon. Amines also have the NH2 group, but they lack the C double bond O. You may encounter aminos used only as side chains and not as their own functional group. Using that convention, the example shown would be 2-aminohexane. Nitriles contain the CN cyanide group with a carbon attached to a nitrogen with a triple bond. The CN will always be on the group and serves as the first carbon. And that's all. Thanks for watching our quick overview of the basic functional groups. If you have any questions, comment them down below and we'll help you out.